Materials types: metals, polymers, ceramics, composites, semiconductors, and biomaterials. 1. Metals. Ferrous metals. Ferrous metals are a category of metals primarily composed of iron and varying amounts of carbon. These metals form the backbone of industrial materials due to their abundant availability, diverse properties, and wide range of applications. Here are some common types of ferrous metals. Steel. Steel is an iron-carbon alloy containing up to 2.1 carbon by weight, along with small amounts of other elements such as manganese, silicon, sulfur, and phosphorus. It is the most widely used ferrous metal due to its excellent strength, durability, and versatility. Steel can be classified into various types based on its carbon content and properties, including carbon steel. Contains primarily iron and carbon with carbon content ranging from 0.5 to 2.1. Alloy steel. Contains additional alloying elements such as chromium, nickel, molybdenum, and vanadium to enhance specific properties like hardness, corrosion resistance, and wear resistance. Stainless steel. Contains chromium, usually 10, 20, and often other alloying elements like nickel and molybdenum, offering high corrosion resistance and strength. Cast iron. Cast iron is an iron-carbon alloy containing more than 2.1 carbon by weight, along with silicon and other alloying elements. It has a lower melting point than steel, making it easier to cast into complex shapes. Cast iron can be further classified into various types based on its microstructure and properties. Gray cast iron contains graphite flakes, providing good machinability and damping capacity. White cast iron contains cementite, iron carbide, offering high hardness and wear resistance. Ductile cast iron. Nodular cast iron contains spherical graphite nodules, providing enhanced ductility, toughness, and impact resistance compared to gray or white cast iron. Wrought iron. Wrought iron is a nearly pure form of iron with a very low carbon content, less than 0.8. It is relatively soft, malleable, and ductile, making it suitable for forging and shaping into various decorative and ornamental products such as gates, railings, and furniture. Wrought iron is less commonly used in modern industrial applications compared to steel and cast iron due to its limited availability and higher cost. Ferrous metals, particularly steel and cast iron, are widely used in various industries, including construction, automotive, manufacturing, infrastructure, and machinery. Their diverse properties and applications make them indispensable materials in modern society. Non-ferrous metals. Non-ferrous metals do not contain iron as the primary constituent. They include a diverse range of metals and alloys such as aluminum, lightweight, corrosion, resistant, and excellent thermal and electrical conductivity. Widely used in aerospace, automotive, construction, packaging, and electronics industries. Copper. High electrical and thermal conductivity, corrosion resistance, and ductility. Used in electrical wiring, plumbing, electronics, heat exchangers, and architectural elements. Lead. Dense, malleable, and low melting point. Used in radiation shielding, batteries, soldering, and as counterweights. Nickel. Good corrosion resistance, high temperature strength, and magnetic properties. Used in stainless steel production, aerospace components, chemical processing equipment, and rechargeable batteries. Tin. Corrosion, resistant, malleable, and low toxicity. Used in soldering, tin plating, tin cans, bearings, and alloying with other metals. Tungsten. Very high melting point, hardness, and density, used in electrical contacts, high-temperature applications, machining tools, and heavy alloys. Cobalt. High magnetic permeability, corrosion resistance, and heat resistance. Used in magnetic materials, superalloys, batteries, and industrial catalysts. Mercury. Liquid at room temperature, high density, and high surface tension. Used in thermometers, barometers, batteries, and electrical switches. Vanadium. High strength, hardness, and resistance to corrosion. Used in steel alloys, aerospace components, chemical processing, and energy storage. Niobium. High melting point, superconducting properties, and corrosion resistance. Used in superalloys, superconductors, nuclear reactors, and medical implants. Silver. High electrical and thermal conductivity, malleability, and ductility. Used in electrical contacts, jewelry, currency, photography, and mirrors. Chromium. High corrosion resistance, hardness, and luster. Used in stainless steel production, decorative plating, aerospace alloys, and in the production of refractory materials. 2. Polymers. Polymers are large molecules composed of repeating structural units called monomers, which are covalently bonded together to form long chains or networks. They are versatile materials with a wide range of properties, making them essential in various industries. Here's an overview of polymers. Classification. Polymers can be classified into several categories based on their structure, properties, and synthesis methods. Thermoplastics. These polymers can be melted and reshaped multiple times on heating. Examples include polyethylene, polypropylene, polystyrene, and polyvinyl chloride PVC. Thermosets. These polymers undergo irreversible cross-linking reactions during curing, resulting in rigid and heat. Resistant materials. Examples include epoxy resins and polyurethanes. Elastomers. These polymers exhibit elastic properties and can return to their original shape after deformation. Examples include natural rubber, synthetic rubber, and elastomeric thermoplastic elastomers. Biopolymers. These polymers are derived from renewable biological sources such as plants, animals, or microorganisms. Examples include cellulose, starch, proteins, and biodegradable polymers, like polylactic acid. Properties. Polymers exhibit a wide range of properties depending on their chemical composition, molecular structure, and processing methods. Mechanical properties. Polymers can have varying degrees of stiffness, strength, toughness, and flexibility. Thermal properties. Polymers can have different melting points, glass transition temperatures, and thermal conductivity. Electrical properties. Polymers can be insulators, semiconductors, or conductors depending on their chemical structure and additives. Chemical resistance. Polymers can be resistant to acids, bases, solvents, and other chemicals depending on their molecular structure. Biocompatibility. Some polymers are biocompatible and suitable for medical and pharmaceutical applications, such as implantable devices and drug delivery systems. Processing. Polymers can be processed using various methods depending on their properties and intended applications. Extrusion. Used for producing continuous shapes such as films, sheets, pipes, and profiles. Injection molding. Used for manufacturing complex, shaped parts with high precision and efficiency. Blow molding. Used for producing hollow containers, such as bottles and containers. Compression molding. Used for molding thermosetting plastics into desired shapes. 3D printing, additive manufacturing. used for rapid prototyping and production of customized parts and products. Applications. Polymers are ubiquitous in modern society and find applications in numerous industries, including packaging example, plastic bags, bottles, containers. Automotive example, interior components, bumpers, tires. Construction example, pipes, insulation, roofing materials. Electronics. Example, cables, connectors, housings. Medical and healthcare example, implants, prosthetics, medical devices. Textiles and clothing example, polyester, nylon, spandex. Agriculture example, mulch films, irrigation pipes. Consumer goods example, toys, furniture, kitchenware. 3. Ceramics. Ceramics are inorganic, non-metallic materials, typically composed of metallic and non-metallic elements bonded together through ionic or covalent bonds. Examples include traditional ceramics, such as pottery, porcelain, and bricks, as well as advanced ceramics like alumina, silicon carbide, and zirconia. Ceramics are known for their high hardness, stiffness, wear resistance, and thermal stability, making them suitable for applications such as construction, electronics, aerospace, and biomedical implants. 4. Composites. Composites are materials composed of two or more distinct constituents with different physical or chemical properties, combined to form a new material with enhanced properties. Examples include fiber-reinforced composites like fiberglass, carbon fiber composites, and particle-reinforced composites such as concrete and wood. Composites offer a combination of properties from their constituent materials, such as high strength, to weight ratio, stiffness, corrosion resistance, and tolerability, making them suitable for aerospace, automotive, sporting goods, and structural applications. 5. Semiconductors. Semiconductors are materials that have electrical conductivity between conductors, metals, and insulators, ceramics, and exhibit sensitivity to external stimuli, such as temperature, light, and electric fields. Examples include silicon, germanium, gallium arsenide, and various semiconductor compounds. Semiconductors are essential in electronics and semiconductor device manufacturing, including integrated circuits, solar cells, LEDs, and electronic sensors. 6. Biomaterials. Biomaterials are materials engineered to interact with biological systems for medical or biological applications. Examples include metals, titanium alloys for orthopedic implants, polymers, biodegradable sutures, ceramics, hydroxyapatite for bone grafts, and composite materials, hydroxyapatite for bone grafts. Biomaterials play a crucial role in medical devices, tissue engineering, drug delivery systems, and regenerative medicine. 7. Natural materials. Natural materials such as wood, stone, and bamboo are valued for their aesthetic appeal, sustainability, and biodegradability. Wood is used in construction, furniture, and interior design for its warmth, texture, and renewable properties. Stone, including granite, marble, and limestone, is employed in architectural projects, monuments, and sculptures for its durability, natural beauty, and weather resistance. Bamboo is prized for its rapid growth, strength, and sustainability, making it suitable for structural elements, flooring, and decorative panels in construction and interior design.